The objective of this project is to build a steamboat and calculate the heat generated, the useful work, and the thermal efficiency produced by it.
The materials used were a carton of milk, 2 cans of soda, a can of solid alcohol, a hanger, a pair of scissors, a knife, a pair of tweezers, a spoon, a syringe, and aluminum foil. To begin, a carton of milk was cut to create the structure of the boat. Then, a can was cut in order to create a holder for the solid alcohol. We then used aluminum foil to cover the walls of the holder. Next, we did a tiny hole on one side of the soda can with a pin and emptied its contact to use it as a container for the water to be heated. Then, the hanger was bent and cut in order to create the support to lift the water container above the heat source. Finally, the container was filled with water using the syringe and glued with silicone to the structure of the boat. The can with solid alcohol is lit and put below the water container. Since the buoyant force is greater than the weight of the boat, this floats. The heat produced is equivalent to the sum of heats needed to heat the water in the container, the aluminum of the container, and the latent heat of evaporation of the water inside the container. The work energy theorem states that the work done is equal to the difference of kinetic energy. Therefore, the work done is equal to the mass of the boat times its velocity squared divided by 2. To determine the velocity of the boat, the time it took the boat to travel a certain distance was measured. To determine the efficiency of our machine, the steamboat, the amount of work done was divided by the total heat produced and multiplied by 100.
The Carnot cycle is an ideal thermal engine, which has the highest efficiency any thermal cycle can have. This cycle states that there is not a system that can have 100% efficiency. The most efficient engines nowadays have around 40 to 50% efficiency, so it was expected that a steamboat built at home did not reach high efficiency levels. Our result was very small due to the fact that there is a great amount of heat lost. The main cause of this loss of heat is given when the can is being heated. It takes a lot of energy to heat the water and change it to steam, and the efficiency work is done by the steam, so most of the energy is lost to heating the water and very little is converted into useful work.